everyone, welcome back to the channel. So today in this video lecture we'll be solving this problem replace word, which is a yet another problem in the try series. So in this problem we first state a concept called a root. So what is a root? It's just a word which when concatenated with another word creates a longer word. So let's call this word a successor. So we basically concatenate the root word with some other word and we form a successor. For instance, we have an as a root word and it is followed by the successor word other. So an is concatenated with other. So we form another. Okay. So and here is the root while other here is successor. Fine. So we are given a dictionary consisting of many roots and a sentence consisting of words separated by spaces. We have to replace all the successors in the sentence with the root forming it. Okay, so there are some successors in the sentence and we want to replace those successors with the root forming those successors. If a successor can be replaced by more than one root, we replace it with the root that has the shortest length, and we have to return the sentence after the replacement. Okay, so let's better understand the problem statement using an example. So here we have an example, and in this example we are given this dictionary which are roots and it contains cat, bat and rat, and this is my sentence basically. The kettle was battled by the battery. Okay, now let's start with the word the. We do not have any word in this dictionary which behaves as the root word for this the. Let's move to the word cattle. We can see that we have a word CAT. So CAT is basically a root word for this word cattle. Okay, so what do we have to do in this problem? We have to replace all of the successors with the roots. Okay, so we replace this cattle with cat. Okay, because cat, we know cat concatenated with TLE gives me cattle. Okay, so this is the root word and this is another root word, and they combine with each other to give me this successor which is present here in the sentence. So was, it is not there, we do not have a root corresponding to this word. Battled, so we have a root corresponding to this battled, which is this one, because bat plus TLED will give me this successor battled. We do not have the root for this by, we do not have the root for the, but we have a root for this battery which is bat. Okay, because bat concatenated with TLED gives me battled, and it concatenated with TARY gives me battery. Fine, so what will be the final sentence? It would be the cat was bat by bat. Fine, the cat was bat by bat. Okay, so it's not rattled, it's battled. Okay, so you got the idea what we want to do in this problem statement. We're given a bunch of words in the form of this dictionary. We're given a sentence. Now pick out the words from this sentence and just try to find the root words for those words in the sentence that we have, like we did here in this example. That's all we have to do. How tries helps us to solve these kind of problems? Let's see that. Now we can see that the idea is very simple. Why do we need tries here? Because whenever I come across a word, like I came across a word here, this one, remember the functionality which we implemented in the tries. that is starts with the prefix function. Fine. So we given a prefix, we just want to check if we have a word in the try which contains that prefix. Okay, now the idea is similar here. We have the word, like we have to just do the converse of that process. We have the word here and just take this as the prefix. We put these prefixes or these root words into the try, and now corresponding to the word in the sentence, we just check if we have a prefix which matches with the prefix of this word. And if there are more than one matching prefixes, then we simply take the one which has the shortest length. Like here, the prefix that I had in the try was cat, which is CAT. Okay, and this is the only prefix which I have in my try. So I replace this cattled with the cat. That's the idea. Now let's just build the corresponding try for this, for the words which we are given. So we are given this cat, bat, rat. So let's build the words for them. Okay, so let's start from the root. So let's first insert this cat into the try. So insert cat. So put C here, then put A, then T, and T is the ending a character in this path. Let's put bat, B A T. Let's put the last word, which is rat. So R A T. Now I have my try prepared. So let's see the sentence which I want to modify. The sentence is the kettle was rattled by the battery. So it is the kettle was battered by the battery. Okay, so that's all. So the process is simple. All we have to do is just like how we gonna implement the solution for this problem is simply split the given sentence into the different words. Okay, so use is string stream function. So is string stream, so it's only one s here, is a string stream function, and let's put the sentence like this in this function. So now this s will contain these words, will contain the words separated. So we'll have the kettle was battled by the battery. They will all be separated, segregated using this object is string stream. Okay, so let's see what we're gonna do then. So start with the very first word, which is the, and just search it in the try. We do not have any prefix for this word, so we put it as it is. So here we are preparing our resultant word. Okay, so this is the resultant word. So just put the as it is. Now move to the next word, which is kettle. Do we have a prefix corresponding to the cattle? Yes, we have CAT. It has a length of 3. So put that prefix here. Replace this word with the prefix. Move to the third word, which is WAS, was. Do I have any prefix related to this word? No. So put it as it is. Move to battled. Do I have a prefix corresponding to this word? Yes, we have it here. Bat. So put bat here instead of battled. Do I have a prefix related to by? No. So put it as it is. Do I have a prefix related to the? No. So put it as it is. Do I have a prefix related to this? No. Was battled by the battery. Okay, so just put bat here. Fine, so this is my resultant word. This is my resultant word, and I return this as my answer. Fine, so I hope you got the idea what I'm gonna do. First, I will be inserting all of the words in the dictionary into the try. That is again done using the insert try function, which we have already discussed in the previous videos. While to search for the prefix, we'll simply just iterate over the words which I have segregated here, and corresponding to the words I will simply prepare the prefix. Like for cattle, what I will be doing is I will create a word, I will create another word, take another temporary prefix. Now prepare the corresponding prefix for from this given word. So prepare C. Now check for it if C is present in the try or not. It is present. It is not present because C is not the ending character. So move to CA. Is CA is present as the proper word? No. So move to the next, which is CAT. Is CAT present in the try as a proper word? Yes, it is here. CAT. That means CAT, like this cattle, can be replaced with this CAT. So I replace it with CAT. Now I do the same for the was. For this word was. I do the same for battled, and so on. Finally, I'll have my answer prepared in this resultant sentence, and I will return that sentence from the end of the function. So that's the idea how we're going to solve this problem. Let's jump to the code implementation part. It's a pretty standard problem. If you have solved the problem, the very first problem, which is implement prefix tree, then it is really easy for you to implement the solution for this problem. So let's first create the try node. So create a try node. Let's create a class for it. So class try node, and in this class let's create a pointer of size 26, children, size 26. Now bool is and. So let's create a constructor which will be try node. So this constructor is going to initialize this children array to 0, and this is and variable to true, to false. Fine, so here I am gonna create a root node. Let's create a function insert, and in this insert function let's create a let's take, okay, I'm gonna insert a word. So let's just insert word, and we have the root for the try, and here I will be initializing this root with the new try node, then iterate over the dictionary word and call this function insert for every word given in the dictionary. So here in this insert function, uh, I'm gonna I'm passing my word which I want to insert in the try. So take a temporary node, let's call it current, and put root in it, iterate over the string. So char c word, then check if we do not have a pointer for the current character, that means store it into the try. C minus a new try node, and move the current pointer to the children node, C minus a. Fine. And here, when we are done with traversing the word, simply mark this is end variable to be true. Okay. Now we are done with the insert function. Let's jump to the next function, which is after insert function we have what we want to do. Yeah, let's take a check function, okay, or replace word function. uh, Check function, okay, check function, it returns a string, let's call it check. It takes in the word which we are passing, like the word which we have extracted from this sentence, which I want to replace with the shortest prefix. Fine, that's what the word which I am getting here. Now from this check function, I just want to find whether this word is present in the try or not. How I'm going to check it? I'm starting from the root node, okay. Now iterate over the word, then for every character in the word, check if it is not there. If it is not there, then return false, return the empty string right from there, okay. So what I'm doing is I'm passing the word here, and I want to check for the prefix. Okay, so let's do it like this. This function, this check function, will take the word which I have separated from here. So I've got a word from here, like for instance here in this example, I I'm passing this word from this sentence, cattle. That's the word I'm talking about here. I'm passing the proper word into this check function, and what this check function does is find me the shortest prefix corresponding to this word which is present in the try. So that's what we do. So to do so, let's create a string, let's call it s. This string will basically will calculate the shortest prefix which is present in the try. So if it is null, then that means we will return this s right from here. Otherwise, concatenate this character and move the current pointer to the next position. And from the ending, if I haven't found this, if I have never encountered this condition, that means we have the entire word present in the dictionary. So in that case, we'll return the entire word as it is. Okay, I think, yeah, that's good. So here, if I want to segregate the sentence into the words, let's take this is stream is string stream, and let's say s, pass the sentence into it. So this object is going to split this this sentence into different words. Now iterate over those words, which will be like, let's call it word. Okay, so word, and iterate over the stream s. Okay, so this is going to, okay, so let's create a string word, and let's create a string answer. So this answer string will basically store the final answer, and this word will iterate over every single word which I have separated here. Now word, iterate over this string and over this stream, and for every word which I am picking here, just check if, call this check function, because this check function will simply return me the appropriate prefix which is there in the try. So call this check function and pass in the word, and after pushing every word into the string into the answer, also push, or let's call it append, let's just add, also append a space at the end of the string. Finally, remove the extra space at the end and return this string answer from the end of this function replace words. Let's check if it works. Okay, it gave me wrong answer. Okay, there's a problem with this, I think. So what is the problem? The problem is that if this current is, and if this marks the ending character, then we return our s right from here. And here, if I have a null pointer for any character, that means I do not have that particular, yeah, that means I do not have that particular prefix which I am searching for. Okay, like I have to return the entire word in this type of case. Okay, so I break in this type of case because what I'm checking here is that if the corresponding children for yeah, now this condition simply checks if the condition, okay, so the problem is simple. So here what I am checking, if the children for the current character points to null, that means this character is not there. That means the word here which I am looking for is not inserted. Okay, the word or any of its prefix was not there in the dictionary. That means in that type of case I have to return the entire word as it is. Like here, the was by they were not there in the dictionary. So I return these kind of words right from the function as it is. So I break from this point. Otherwise, I just add the character into the string and move to the next pointer which is available and check if this current marks the ending. If it marks the ending, means the prefix which I have prepared till now for this word is present in the try. So I return that prefix from the function. So let's just see if it works or not. It worked, so let's submit it. Okay, so it got accepted. Let's just discuss the time and space complexity. Again, for insert, what I'm consuming is I'm inserting n words, and if one word has a length of average length of m, then this will be the time complexity big of n into m. While for the replace for the function which is the check function, okay. So if we have let's say n words, or let's say k words into the sentence which I have segregated, and I'm calling the check function for every word, and the complexity for the check function is m, where m is basically the average length of the word in the sentence. So that will be the time complexity for iterating over every word and checking whether the word or its prefix exists or not. So the overall time complexity would be n plus k into m. Fine, so that's all. While the space complexity is same as it is for the tries. So that's all for this video. If you like the video, then hit the like button and subscribe to the YouTube channel, and stay tuned with me in the series, in the try series. We'll be solving harder problems as well, and I hope to see you all people in my next video. Till then, take care. Bye bye.